Hello everyone, I hope you guys are doing great and hope you enjoyed the session 1 of this architecture series. Okay, so in this today's second session, we will talk about software design and architecture. Basically, the difference between these two terms. And once this session is over, you will understand few things. One is you will understand what is the difference between architecture and design. You will learn about a decision mechanism, a simple small exercise which you can use to understand whether a topic is architectural or more on the design side, or it lies uh, in both the categories, architectural and design categories. And third, you will understand why this information is important and what you can do with this information. So here you can see there is a house, and whenever we want a house built, we need to talk to architect also, and we need to talk to the designer also. Okay, so in general the discussions with the architect are like how many rooms you need in the house, where should be the kitchen, how big bathrooms you need, how many floors you need, how it will connect to the water, electricity, etc., right, utilities. So how those things will be managed. And when you talk to a designer, you will talk about things like how lighting is needed in the house, how will your walls look like, how your living room setup will look like, how your kitchen cabinets will look like, right? So basically, when you talk to the architect, you talk about the big picture, right? And when you talk to the designer, you talk about the inside story. So it's a simple way to remember that when you talk about big picture, it's more about the architecture, and when you talk about the inside story, you talk about the designer. You need both architect and designer, and who knows, one person can be the both, right? So if we extend this analogy to our software, and let's say we want to design a e-commerce site, then what are the things you want to talk about in architecture? So for example, you want to talk about the cloud provider, you want to talk about the database type, not which database, but the database type, SQL, NoSQL, or any other data type, right? You would like to talk about the architectural style, right? Microservices, deployment model, you want to decide whether you want to deploy it on on-prem virtual machine, whether you want to deploy on a cloud using Kubernetes, or you want to you want to deploy it on AWS Fargate instance, right? Security protocols, which security protocols you want to use, whether you want to secure your data also, whether you want to secure data at rest or um, in the wire, right? So these are the things generally we cover in the architecture. So big picture is architecture here, and when we talk about inside story, and in terms of a website or a software, design is generally about database schema, right? What database schema you want to use, how you want to structure your classes, how you want to structure your code, how you want to use your design patterns, how your UI layout will be, right? And how your objects will be relating to each other. So if you are using microservices, you must have decided your domain objects and how those objects will talk to each other, or how they will be arranged in the system, right? So it's more about what is going inside the system, right? So this is the high level difference between architecture and design. If I ask you one question now, that merging two microservice, is it architectural stuff or design stuff? Or let's say you want to break an existing microservice into two parts. Will it be an architectural decision, or will it be an design decision? Or to complete this work, do I need to focus on architecture or do I need to focus on design? Right? So can you answer these questions? For example, you need to change the persistence framework in your application. Is it a design item or a architectural item? Right? Or both? So there is no standard framework, but there are a lot of ways which products use, and there are a lot of ways which are books, literature, a lot of people with the experience talk about. So first is strategic or tactical. So we need to decide whether a particular item is a strategic decision or a tactical decision. What are strategic decisions? So high level, long term decisions, these are the strategic decisions. So for example, you took a decision at a very high level and this is going to impact the system for a long time, right? Then it generally comes in the strategic direction. For example, microservice or monolithic, right? So this is a high level, right? You are not going inside the system right now, and this is going to impact your system for the long term. So this is a strategic decision. And if you want to choose algorithm for a specific feature, so in your system there is a very specific feature and you want to use an algorithm for it. So generally it is, when you are talking about algorithm, generally you are inside the system, so it's not high level now, right? Will it impact for a long time? Maybe, maybe not, depending upon if it do not work well, can I change it easily? Yes, if I can change it easily, then it's not that long term, right? If I'm choosing an algorithm for a small thing in my logic, then it's more of a designer stuff. Next is high versus low efforts. So if a topic needs high effort generally do not mean the efforts to implement something, right? But it's more about planning, coordination, and resources. So if a topic needs lot of planning, lot of coordination, and lot of resources, then it is a high effort item, right? For example, implementing cross-cutting concerns like security and scalability. So I have to implement the scalability in my system. Then it's a high effort stuff because we need to plan it well in advance. We need to coordinate with different team members, different stakeholders, right? When scalability is a need, then we need scalability is not a small stuff. When you want your system which is not scalable today and you want it to be scalable tomorrow, it's like multiple instances running in parallel, lot of things can break, right? So you need to talk to developers also to understand a lot of stuff. You need help of your tech leads also. So generally people who have expertise, right, they all are needed here. So this is a high effort topic, right? And we need to plan it. If we want to make a system scalable, we want to test it, we want to do a lot of other stuff with it, then we need to plan a lot of stuff. And if I am implementing a very specific feature within a service, so there is a service, a requirement came in and I just need to implement something inside it. It's a low effort item. Low effort not in the terms that it is implemented in 1 day, 2 day or 10 day, right? But it generally do not need involvement of architectural decisions. Team can take care of these things. It do not need a lot of planning. A requirement came in, stories are broken down in the right shape, and now team can start picking up. So not much planning required, not much coordination is required, right? Not extra resources are required. It's like a regular day-to-day life work. So this is a low effort stuff. Next is significant versus less significant trade-offs. Okay. So if there is a work item and you have to decide whether it is architectural or design, then you need to think of in a way that if I work on this item, are there huge trade-offs? So for example, is it impacting my non-functional principles in a way? Is there anything important which I'm losing in my system, right? So for example, let's say if you read it here, it says major decisions that can have a substantial impact on the system's success or failure. For example, work item is convert this monolith to microservice, right? Okay, then we will decide the domain, we will break them into a lot of parts. But will it impact the performance? If yes, and if I am not able to meet my SLAs, if I am not able to process the load as fast as it was expected, then of course this is a failure, right? So trade-off is huge here. We are having a trade-off on the performance. For example, here choosing between eventual consistency and strong consistency is significant trade-off. So let's say I decided that okay, my system is today eventual consistent and I want to make it a strong consistency. Okay, then in that case I need to think a lot about that to whichever distributed component I'm talking. For example, cache or maybe messaging or maybe databases, right? And I want everything to be strongly consistent, then it may impact performance also, right? So I need to think a lot about it, and losing the performance or slowing down the system, right? It's a significant trade-off. And it's vice versa also. For example, your system is strongly consistent and you want it to be eventual consistent, right? To increase the performance. But again, the point is, if there are certain APIs which are pulling the data from certain database, and because of eventual consistency, there is a possibility it might not get the data at the right time. So you might need to think about that. Okay, this is a trade-off. Trade-off is that okay, your customers might not get the data, your user experience is impacting, right? So items like this are generally under the significant trade-offs category. Choosing between two similar libraries for a specific feature. So for example, you have to do the XML parsing, right? So for XML parsing, let's say there are three libraries, and if you choose one, which library I choose will not impact something very hugely, right? It will not change my architecture style. It will not impact my architectural decisions. There might be some changes. There might be some problems. Let's say my library is not that performant. Then I can change the library, right? I need not to change my whole application. I need not to talk to the whole all the stakeholders, right? So this is a here we are not having very significant trade-offs in choosing one library or other, right? So is there any way to measure exactly that whether the item is in which category? So this is a scale, and these are the characteristics, or these are the three things we talked about. Now what we can do, we can think about those three things and we can try to give some marks, right? So first is like, for example, I need to decide whether this item is a tactical decision or a strategic decision, right? I will put it on this scale, and same way, whether it's a low effort or high effort, I'll put it here somewhere, right? If it is not taking too much effort or it is very low effort, then I will put it here, right, on this side. And if there are huge trade-offs, I will put it this side. Merging two microservices, I have put it as a strategic decision. Okay, so why strategic decision? Because it's a long term and it's high level, right? When we are talking about merging two microservices, I need not to go inside the service to understand, just to say that okay, we need to merge these two microservices. Okay, it's a high level decision and it's going to impact for the long term. So let's say my system is having my system is having 9 microservices. Now it will have only 8 microservices, right? Once I merge. So it's a long term. So that's why I put it as a strategic decision. In your case, you can put it anywhere you want, right? Is it a low effort or high effort? I have put it as a bit high effort because I may need to talk to the lot of stakeholders. I may need to do the communication. I may need to talk to the team members. I may need to change my packaging, right? I may need to change my deliveries, or I may need to update my documents. I may need to communicate my stakeholders, and I may need to think of the reasons why I'm changing. For example, I'm changing to increase the performance. Then we need to think about that after merging, has the performance really improved? How to test it? So it's like lot of stakeholders, lot of coordination is required. So that's why I have put it as a high effort item, right? It's not very high, but it's not that it's very less. So it's on the higher side. And next is trade-offs. So it may be different in your case, but in my case, I have kept it on the low side because I'm merging my two microservices. I'm not changing something very huge at the architectural dimension level. Okay, my components are reducing, that's it, but I am still on microservices. I have taken the score as 1, this one is 6.5, this one I have taken 9.5 and divided by 3. So total average of these three is somewhat on the higher side or somewhat on towards the architecture side. So generally we can say the items which are towards the design side, they are having less architectural stuff to be done, and items which are more towards the architecture side, or maybe they are just here, they are purely architectural stuff. And uh, in practical and in real world, most of the items will lie somewhere in between, right? So it will need the design and architecture to be thought through together, right? So now the point is, when now let's say I pick up an item and I use this strategy to decide whether it is design or architecture. What should I do with this information? Why do I even need this information? So the reason is here. With the help of this information, you can prioritize your decisions. For example, you can focus more time and effort on architectural choices as they have a wider impact. You can allocate your resources wisely. For example, if it is an architectural stuff, then you may need to think of the time of the person who is responsible for architecture. And if it is less on the architecture side, maybe your teams can handle it, your developers can handle it, right? And if it is somewhere in between, then yes, developers or teams can work on it with the collaboration with architect, right? In collaboration with the architect, right? Manage risk efficiently. Of course, if there's an item on the architecture side, I may want to focus more on it in the sense that I may not want to pick this item towards the end of the release. I may want to pick it up as early as possible, right? And once we are done with the architectural stuff, then probably team can start working on design part, or architect can coordinate with the team for the design part, right? And there is nothing harm in doing it yourself also. Clarify roles. So this will help in identifying, okay, which person should be able to do it, right? Handle changes smarter. Of course, when you are doing architectural changes, you may want to iterate over your design, right? But for that, you need to plan it well, and you need to understand well in advance that, okay, this is a complex stuff we need to do. This is a complex piece of architecture. And when we will implement, there is a chance that design may not be perfect. It may need to evolve. So if you can keep an eye on it well in advance, then there are good chances your design will have enough scope of the improvement, right? So you can be creative, you can use this information in any way. And that's all for this session. And in the next session, we will talk about more in depth of the architectural characteristics. One of the architecture dimension we talked about in first session. So thank you for watching this video. If you have any questions, any queries, please leave the comment. Any feedback, that's perfectly fine. You can leave it. And have fun. Happy learning. Bye.